We're going to be talking today a little bit more about our greatest common factor and our least common multiple in a couple of different videos today, and why it's so important to know what factors are and multiples and when we're going to use them. So we're going to start out with the greatest common factor, and one example where we're going to use factors is when we put things in simplest form. So if I have the fraction 24/36, if I can find the greatest common factor of that, then I can use that to help get it in simplest form. So they've got it written in greatest common factor form for us, and they've already done the work and know the greatest common factor is 12. Again, if you wanted to do a grid method to show that, like we've been studying, we know we have 24 and 36, and we can pull out those common factors. And a lot of times you can use 2 because these are both even, but if you can come up with a larger one first, you can get this in less steps. For example, I know both of these can divide by 6, so I'm going to start with that. And I know 24 divided by 6 is 4, and 36 divided by 6 is 6. So I'm still left with a 4 and a 6, and I know those are not relatively prime yet because I know they're both even. They can both divide by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. And now I know I'm done because 2 and 3 are relatively prime. So notice, it divided by 6 and it divided by 2, so I know the greatest common factor is 12. Because remember, with the grid method, we can multiply 6 times 2. If I divide by 6 and I divide by 2, then I actually divided by 12. So I can get this in one step. So if you notice right here in the example, if I take 24/36 and divide both the top and the bottom by 12. Remember, if I divide them by 12 and 12, you're dividing by 1. 12 twelfths is 1. So the value stays the same, and that gets it down to 2/3 in simplest form. And almost all of our work, going forward, we're going to want to get into simplest form. So we use factors a lot. So we really want to know how to find those greatest common factors and use those to help us get things in simplest form. Okay, so for an example, if I want to find and get these 12/18 into simplest form, to write it in GCF form, we say the greatest common factor of 12 and 18. And I need to find that greatest common factor to know what I'm going to divide by over here to get it into simplest form. Again, I could use my grid method. I just showed that here. But a lot of times, when the numbers and the terms are smaller, a lot of times you might just know what they are. Like I know 12 and 18 can both divide by 6. All right, so that's probably the greatest common factor in this case. So I'm going to say the greatest common factor is 6. And then I'm going to use that to help me here. Okay, so I'm going to divide those fractions, those numbers, 12 and 18, both by 6. 12 divided by 6 is 2. And 18 divided by 6 is 3. And now I've changed 12/18 and got it into simplest form of 2/3. And I know these are relatively prime, so that's in simplest form. Okay, pretty easy when some of these numbers are smaller in these terms, but when they get bigger terms, sometimes you're going to have to use that grid method again to find that greatest common factor and be able to use that to get it in simplest form. Okay, sometimes you guys will find out you can do this sometimes and not use the greatest common factor. I kind of call it the guess method. If I have 12/18 and I know they're both even, I know they both divide by 2, so I could just do this dividing by my identity property by 2 halves this time. In this case, that would change it to 6/9. And if I know my terms and my factors, I also know that these can both divide by 3. So I can divide by 3, and that changes it to 2/3. Again, it got to the same thing here. I was able to do it in one step, so it's a little more efficient if you can do it with the greatest common factor. But there's nothing wrong with choosing any factor and then lowering those terms and picking another factor until you get it down into simplest form. So you guys will be using the factors a lot, and that's why we stress so many times trying to figure out the greatest common factor and what are the difference between factors and multiples. Okay, so you'll be using that for problems like this to practice today, really working on getting things in simplest form. We also have some word problems and seeing how these go along with that. So I want to look real quick at number 3 here as just one example. A gym class of 30 boys and 45 girls is divided into groups. Each group has the same number of students, and each group only has boys or only girls. So I want to know the greatest possible group size if every student participates. The greatest possible group size. So I'm going to show some work up in here. I've got 30 boys, and we can kind of write this like a fraction if you like to. And we have 45 girls. And our job is to find the greatest group size possible. Again, that's basically just the greatest common factor. And I know my facts here, and I'm not going to need to do the grid method, but I could. I know these both can divide by 15. So if I divide them both by 15, 30 divided by 15 is 2, and 45 divided by 15 is 3, and I get it down to 2 and 3, and I know that's relatively prime, then I know 15 is my answer. That's my greatest common factor. So 15 is the GCF. So the largest possible group size I could have would be groups of 15. And the GCF is my answer in this case. It's 15. So there's some real world type problems that you can see where you would use greatest common factors. So this is another example again of how we use factors and use them a lot in math things that we'll be doing with fractions.